So we wanted to start this morning with an overview of the AESQ, give a little bit about our history, why we formed, and where we're headed. So if we think about the view from 2013, which is when AESQ formed, there was unprecedented production ramp ahead for all of us. There was an expanding global supplier footprint. So our suppliers became more diverse around the globe. They weren't so local anymore. There was an increasing supplier engine content. So we went from making many of the engine components ourselves to buying the parts, having them supplied, and working collaboratively with suppliers to produce them for us. Upwards of 80% for some engine programs are procured supplier parts. We had a common supply base. As you think about the large engine manufacturers, the OEMs, Safran, Rolls-Royce, Pratt & Whitney, GE, we actually have a lot of suppliers in common. As a supplier, think about if you produce parts for just one of us, most of you produce parts for 2 or 3 of us. So we were flowing requirements to you individually that were unique. Customers were requiring or demanding, I would say, that the engine OEMs improve management of the supply base. Most of us have some military engines that we manufacture, commercial engines. Back in 2012 and 2013, our customers of the engines were demanding that we improve quality. So the Aerospace Engine Supplier Quality Group was formed. And it was formed to supplement AS 9100. People would question, why not just 9100? That's the aerospace and defense quality requirements. We are a subgroup within there. I will tell you, due to the critical safety nature of engines, we needed to do better. AS 9100 wasn't enough. If you think about how that applies to various components in the aerospace industry, the requirements of AS 9100 apply to engines. They also apply to the food that's put in the survival kits. The M&Ms that go into survival kits comply with AS 9100. There's a little difference. It's critical that we all understand that these requirements are to assure safety and quality for our customers, for all of us, for our families that fly, for our militaries that protect freedoms in the world. And so the AESQ was formed. If you think back to 2013 on the left, we all, as engine manufacturers, receive requirements to us for our engines. Regulators, EASA, the FAA, they flow requirements to us. There's customer requirements, Airbus, Boeing, military customer. There's industry requirements. There's flowed NADCAP, AS 9100, ISO. And what we did is we each took all of those requirements, and we made our own standards. So Rolls-Royce flowed Sabre, GE flowed S1000, Pratt & Whitney AESQ 01, and Safran Safe. So what that meant was that as a supplier, you needed to take sometimes 100-page documents from each of us and decode them, understand them, and make sure that you're compliant to them if you were manufacturing for multiple OEMs. There are companies that have people focused on each of us just to decipher the requirements. So we got together, formed AESQ, and it's a collaboration. We went through a lot of legal hurdles to be able to collaborate because we are competitors. But I will, stand here to tell you we are not competitors in safety and quality. All of us have the same vision. We are in common and harmonized in driving safety and quality. If we don't have that, we don't have an industry. So we got together and formed the AESQ. Now, what came out of that was that we decided that we needed a standard to commonize those requirements. We heard from you, it was confusing to have what were very similar requirements flowed to you in different ways, in different language. We all did our own thing with words and spun the terminology. And so we commonized on the AS 13100 standard. Now, we didn't get there right away. We actually created standards for some of the tools first and built up, and then realized, no, this all needs to roll into one standard. And let's harmonize on that. And I'm here to say candidly, we're not 100% harmonized. We still have some requirements we flow separately that we have not yet been able to come together and align on. But about 80% of the requirements that used to reside in these separate requirement documents from each of the OEMs is now embedded into AS 13100. So it replaced a lot of the requirements that we used to flow, and we commonized. Again, they were similar. There's not a lot new in here. But we used terminology so that we're all aligned with one requirement now. So that little last bit, the 20% or so, that we are not yet harmonized on, we continue to work it. There will be a revision of AS 13100 coming out, the first revision. We're harmonizing a little bit further. There are some things that still won't be harmonized. But our objective is to get there. So it's a journey. And the vision of the AESQ is to enable and accelerate the achievement of zero defects and a quality-first culture across the global Aero engine supply chain. And we do that so that we're assuring safety. That disruption is reduced. So there's a business impact. If we had a zero defect world in aerospace engines, we would have flow in our factories. We wouldn't be stopping product at final inspection. We wouldn't be holding trucks to make sure this other thing here is right. We would enable flow, and we'd reduce cost. And it's through the collaboration of the large engine manufacturers and key suppliers like GKN that we're doing this. It's a shared learning journey. And we're developing capability and expertise. And the AESQ is here to support you. We are implementing simplified and common standards. So it's really the AS 13100 standard. I have competition. So why is 13100 important? All engine manufacturers are driving process control and prevention of defects through APQP. We have the same foundational requirements, but we were flowing it in different ways, different terms, different processes, different tools. We needed a simpler and more consistent guidance for the supply base. We were also asked by all of you for a way to share best practices from across the industry and to raise the bar of performance for product safety and quality for the entire industry. And it's essential to support supplier capability through common development and training. So the AESQ has created training to support the deployment of AS 13100. These are the member companies of the AESQ. So the top 10 are the steering group members: GE Aerospace, Pratt & Whitney, Rolls-Royce, Safran, MTU, GKN Aerospace, Honeywell Aerospace, Howmet, IHI, and PCC. And then we also have contributing members. And this keeps growing as we get more and more membership applications. These are companies that would like to be a part of the AESQ and help determine that future of zero defects. Barnes Aerospace, Cincinnati Thermal Spray, Collins Aerospace, Consolidated Precision Products, CPP, ITP Aero, and several of these are in the room today as well. Parker Meggitt, Rolled Alloys, Solar Atmospheres, and Woodward. And we encourage anyone interested to inquire on our website about AESQ membership. I'm just showing faces of the steering group members. These are the voting members from the member companies. Myself from Pratt & Whitney. And then we have GE Aerospace, Barbara Negroe, Helen, who was on the stage earlier from GKN, Dave Halpin from Rolls-Royce, Dennis Poitier from Safran, June Sakai is in the room from IHI, Barry Hicklin is also in the room from Honeywell, Philip Earhart from MTU is here, Dan Carroll from Precision Cast Parts, and Ken Ham from Howmet Engine Systems. So please, I encourage you to go up to us if you have questions or just want to meet during the breaks. Please, members actually have a blue banner on their badges so you can identify members of AESQ. So how is AESQ different? We created the standard AS 13100 to strive for zero defects. AESQ is here to partner with you. This is different. We don't just flow you a standard and walk away. We're here as a partner. We're here to help educate and support. We know it's not easy. We're doing it ourselves. We know it's not easy, but it's imperative. And supplier forums are a great place to start. So again, thank you all for coming. I hope you're learning something and will learn over the course of the next day and a half. And you'll hear more about what's in AS 13100. We'll share how to identify and surpass challenges in your companies. We're going to ask you to reflect on your own challenges at your organization and help support you to work through that. We're going to talk about the roles and responsibilities that are critical to making this system work. It's a system. It doesn't just require quality. The quality professionals. We need design engineering all in. We need manufacturing engineering all in. If we're not designing producible engines, then quality doesn't have a fighting chance. And so you will go home with some tools to get started. You'll meet us, but let's first look at how this does work together as a system.
Today, more than 3 billion passengers travel by air every year, and this is set to double over the next 20 years. These air passengers trust us with their lives. Naturally, our customers expect us to deliver defect-free products and services every single time. After all, that's our promise. But how do we guarantee zero defects when we know that inspection can never be 100% effective at sorting the good from the bad? The answer is to avoid producing defects in the first place. To this end, defect prevention activities are built into our advanced product quality planning and process control requirements as an end-to-end process, with each step being integral to defect-free production. Here's how it works. Firstly, we have product quality planning. This is where the design team works directly with the customer to understand what the product needs to do. From this, a product design can be created. Cross-functional teams then carry out design risk analysis to ensure that potential design risks are identified, understood, and mitigated. There are a number of ways this might be carried out. For example, by using a design failure mode and effects analysis tool. Next, the team designs and develops a capable manufacturing process to make the product. Any risk of this process bringing about non-conformance is evaluated using a process FMEA, and any such risks are mitigated to ensure that the manufacturing or assembly process will produce defect-free products. The appropriate levels of defect prevention controls are defined using the relevant information. For high-severity risks, we must strive for mistake-proofing, while we can address other risks through statistical process control, inspection, or audit. All this is captured in the control plan. We then ensure the capability of the measurement and visual inspection methods required by the control plan. Once verified, we can start to measure the capability of the process to ensure it makes defect-free parts. The Delegated Product Release Verification Program provides a common standard for inspector competency and qualifications. Once in production, the role of manufacturing and assembly is not just to maintain the initial capability level, but to continually improve it to ensure customer and business targets are met. Moreover, data from our processes and inspection must be used to control the process by allowing us to take action before defects are made. If things do go wrong, our problem-solving process must identify and eliminate the root cause so that it cannot happen again. Furthermore, learning from the investigation needs to be fed back into the FMEA, enabling it to be captured and shared. The Aero Engine Supplier Quality Group standards have been created to provide clear requirements on how these defect prevention tools are to be effectively deployed. There is a clear expectation that each of us will deploy these requirements and cascade them down through our supply chain. The final stage of our defect prevention process is an effective audit of the quality system, manufacturing processes, products, and special processes. This review reinforces compliance and can identify further opportunities for improvement. Of course, to be effective, all these tools rely on good cross-functional working and leadership that creates an environment intolerant of non-conformance. After all, defect prevention is a key route to achieving our promise of defect-free products and services. AESQ, raising the standard for quality.